Hi friends, the carbon atom in acetylene is more electronegative or it is sp hybridized than the carbon atom in ethylene. The carbon atom in ethylene is sp2 hybridized, but the chemical shift value for acetylenic proton are less or it is more shielded than the ethylenic proton. What is the reason? Usually electronegative element attached to carbon bearing proton is usually increase the chemical shift of that proton. But even though acetylenic carbon is more electronegative, that is sp hybridized carbon is usually highly electronegative compared to sp2 and sp3 hybridized carbon. Even though this carbon atom is more electronegative, the proton bearing or the proton present in this acetylene molecule is usually has low chemical shift value, or we can say acetylenic proton are less having less chemical shift, or it is more shielded than the ethylenic proton. Such anomalous behavior can be explained on the basis of a very important property called anisotropic effect. It is usually produced by the circulation of pi electrons under the influence of applied magnetic field. The pi electrons start to circulate when such molecules with a pi bond is placed in an external magnetic field. The property anisotropic effect is due to the circulation of these pi electrons under the influence of the applied external magnetic field. Anisotropy is usually uneven magnetic field in space. Uneven magnetic field. Different magnetic field in different area of the molecule. That is, different region of space are characterized by different magnetic field strength. The anisotropic effect depends on the orientation of molecules with respect to applied magnetic field. How the molecule oriented, or the anisotropy is usually depends on the orientation of the molecule with respect to the external magnetic field. In this video, I will be discussing this property, anisotropic effect of ethene, aldehydes, benzenes, cyclophanes, annulenes, and acetylenes. How these molecules show anisotropic effect, whereby its chemical shift gets affected. How is the chemical shift gets affected by this peculiar property of this molecule known as anisotropic effect? This will be discussed in this video. Ethylene is planar. When the ethylene molecule is placed in an external magnetic field, the pi electrons started to circulate perpendicular to the magnetic field. Perpendicular to the magnetic field. This pi electron begins to circulate in this external magnetic field, and hence a ring current is produced, and this ring current produce an induced magnetic field, a secondary magnetic field, which is perpendicular to the the plane of circulating electron cloud, and the field line is passed through the hydrogen atom oriented in the plane. It is passed, these are the field lines which is passed through the hydrogen atom of the ethylene molecule. You can see the field lines are passing through the hydrogen atom in both sides. It is actually along the direction of the applied magnetic field. It is the field line of the secondary magnetic field produced by the circulating electron is actually along the direction of the external magnetic field. Thereby, it reinforces the applied magnetic field, and hence the effective magnetic field experienced by the protons of ethylene molecule gets increases. That means the protons gets deshielded. It becomes deshielded because of the reinforced applied magnetic field experienced by the protons of ethylene molecule. Okay, and hence the delta value of protons of ethylene molecule gets increases, and this property is called the anisotropic property in ethylene molecule. Okay, the high value of chemical shift of protons of aldehyde also can be explained similarly as that in the ethylene molecule. For example, the pi electrons of this carbonyl group begins to circulate when the aldehyde is placed in the external magnetic field. And this circulating pi electron of this carbonyl group produce an induced secondary magnetic field, and see this magnetic field direction or the field lines are passing through the pi electron cloud and also through the hydrogen atom of aldehyde. These field lines are passing through the hydrogen atom of the aldehyde. Thereby, and these field lines, is in the same direction or along the same direction of the external magnetic field, and hence the magnetic field experienced by this proton is actually increased, or it becomes reinforced by this secondary magnetic field, and hence the effective magnetic field experienced by this proton increases. Thereby this proton gets de-shielded, and hence its chemical shift value or delta also increases, and this property is called anisotropic effect. Okay, the high value of protons of benzene is also can be explained by anisotropic effect. The protons of this benzene ring or hydrogen nuclei of benzene ring usually uh, exhibit a high chemical shift value around 7 to 10 parts per million. It is because there are 6 pi electrons. When this benzene is placed in the external magnetic field, this electron cloud begins to circulate with the 6 pi electron, or the 6 pi electrons are beginning to circulate in external magnetic field. Thereby the circulating electron current produce, or ring current produce, an external secondary magnetic field. You can see the field lines are passing through the hydrogen atom in the benzene ring, or hydrogen nuclei of the benzene ring. It is passing through the hydrogen nuclei of the benzene ring, and it is paramagnetic in hydrogen atom, whereas it is diamagnetic in the cavity of this pi electron cloud, or the center of this benzene ring. Here it opposes the external magnetic field, but it is when it is passing through the hydrogen atom, it reinforces the external magnetic field, and hence more and more external magnetic field is experienced by each of the hydrogen atom of benzene ring, or this uh, anisotropic effect usually reinforces the applied magnetic field, and hence the effective magnetic field experienced by each proton gets increases. Thereby we can say protons are de-shielded, and hence its chemical shift value or delta value increases because of the anisotropic effect. See, it is a cyclophane molecule. Cyclophane molecule. You can see the chemical shift value of protons of these cyclophane molecules. Here you can see this CH2 and this CH2. Through the protons of these two CH2, the secondary magnetic field or field lines of secondary magnetic field, as in the case of benzene ring, is passed through, and hence these protons gets de-shielded. You can see it is 1.54 parts per million, whereas you can see the CH2 group here. In this case, it is shielding zone of this molecule. Here it is 0.73, highly shielded. The protons of these CH2 molecules are highly shielded. You can see the chemical shift value of this proton is 0.51. These protons also 0.51. It is because these are placed in the shielding zone of the secondary magnetic field. Thereby the annulenes shows different chemical shifts according to the anisotropic effect it feels. For example, you can see these CH2 and these CH2 on either side. The protons of these methyl groups are highly de-shielded. Thereby it exhibits a chemical shift value of 1.54 angstrom. These are in the de-shielding zone, whereas these protons, these 4 protons among them, this CH2 and this CH2, the protons having the chemical shift value of 0.73, whereas these protons are having the chemical shift value 0.51 parts per million, because these 4 CH2 groups are in the shielding zone, whereas these 2 CH2 groups are in the de-shielding zone. And these are also can be explained on the basis of anisotropic effect. It is because of the anisotropic effect caused by the circulating pi electrons of the benzene ring. Okay. A similar effect is observed in 14 annuline also. It is 14 annuline. The protons outside the ring are strongly de-shielded because of the secondary magnetic field caused by the circulating pi electrons of this annuline, 14 annuline, and produce a signal at around 8 parts per million. Whereas inside the ring protons are strongly shielded. That is why these inside protons show a chemical shift around 1.8 parts per million. Okay, this effect is called the anisotropic effect in 14 annuline. But contrary to all these examples, in the case of alkane, alkane molecule, when placed in an external magnetic field, is so oriented that the plane of the triple bond lies parallel to the direction of the applied magnetic field, whereby the induced magnetic field caused by the circulation of pi electron of the triple bond is in the opposite direction of the applied field in the region of acetylenic proton. You can see acetylene is linear. The secondary magnetic field caused by the circulation of the pi electron of acetylene, which is actually so oriented in the parallel direction of the applied magnetic field, but the secondary or the induced magnetic field by the circulation of this pi electron is passing through the hydrogen atom of acetylene molecule. You can see the magnetic field lines are passing through the hydrogen atom, which opposes the external magnetic field or applied magnetic field. Thereby, actually this proton gets shielded, or a diamagnetic, or the hydrogen is actually diamagnetic in the direction of applied magnetic field. Thereby, its chemical shift value decreases, or it gets shielded, and this property is abnormal, even though acetylenic carbon atom is sp hybridized, more strongly electronegative. The proton attached to this electronegative carbon atom shows lesser value of chemical shift, or it gets shielded instead of de-shielding. The acetylenic proton is found to be shielded because this diamagnetic anisotropy caused by the acetylenic, or the circulation of caused by the circulation of pi electrons of acetylene, which is diamagnetic in the case of proton of acetylene, because the magnetic field the circulating induced magnetic secondary magnetic field lines are passing through the proton of acetylene, which opposes the external applied magnetic field. Thereby, it gets shielded, and hence its chemical shift value usually decreased, or it exhibit low chemical shift value. That is because of this diamagnetic anisotropy in the case of acetylenic proton. With this discussion, I hereby conclude this video. Thank you for watching. Thank you.